Hello everyone, welcome to one more episode of Live Discussion. Today I again welcome Mr. Ashwini Kumar Sinha and Suresh Dwivedi ji for discussing a topic that is Varactor diode and how and where it is used. So let us start with very basic question that what is a Varactor diode and how does it work?
Yeah, so generally vector diode also sometimes be called as a tuning diode or varicap because it's a diode and a capacitor. You can say it's a combination of both. So it can act as a diode and also act as a capacitor. So when it is in reverse biased, when the diode is in reverse biased, it acts as a capacitor. That's why we called it a varactor diode or it's tuning diode or varicap diode. Varicap diode, variable capacitor diode. Yeah. So what happened when you reverse biased it? You can control its capacitance uh, using decreasing or increasing the voltage. So when you reverse bias the diode, and when the reverse biased voltage get increases, the depletion region widens, and this reduce the capacitance of the whole thing. And when it is in reversed biased, uh, and the voltage decreases, the depletion region got narrower, and that's why it increased, the capacitance value got increased up. So that's why we also call it the variable capacitor. It also acts as a variable capacitor. So yeah, also acting as a diode, it also acts as a capacitors as well. So if it is in forward bias, it works like a diode. It allows the electricity to current flow through it. If it is in reverse bias, then it acts as a capacitor, and that capacitance can be increased or decreased uh, based on the what's it voltage of the reverse bias. So this is just amazing device. This is just amazing, you can say, this discrete component. This is just amazing discrete component that act as a both diode and a capacitor, and using this you can save a lots of, you know, external need of external capacitor, because the same device is working as both thing. And it also helps you in reducing the bill of material, also the shape and size of the whole design. So it's very good in those kind of factor where the single component acting as a both thing. And generally it is used in the RF microwave circuits, or voltage control oscillators, tunable filters, frequency modulations, and automatic frequency control. All these kind of jobs, it can be used there.
Okay. So how does the capacitance of a Varactor diode change with applied voltage?
Actually, the capacitance of the varactor diode changes with the applied reverse voltage in an inverse relationship. A varactor diode, also known as a varicap diode, functions as a voltage controlled capacitor and operates under reverse bias. Instead of conducting current, it relies on changes in its depletion region in Vd capacitance. When the reverse voltage increases, the depletion region of the diode widens. This increases the separation between charge carrier, reduces the diode's capacitance. Conversely, when the reverse voltage decreases, the depletion region becomes narrower, allowing for a higher capacitance. It has some simple formula which is easily available on the net. So this change happens smoothly and predictably, making varactor diode useful in electronic circuits requiring variable capacitance. Varactor diodes are widely used in radio frequencies, normally known as RF, applications, including frequency tuning radios, televisions, and communication systems. They are also essential in voltage control oscillators and the frequency modulators, where precise control of capacitance is necessary. So their ability to adjust capacitance without the mechanical tuning makes them ideal for the modern electronics. That's all.
Okay, so what is the typical voltage range for operating a Varactor diode?
Actually, the typical operating voltage range for a Varactor diode depends on its design and the application. But it is generally fall between 1 volt to 30 volt. When we are considering for the low voltage uh, and tuning application, such as a radio receiver and TV tuners, Varactor diodes usually operates within 1 volt to 10 volt. In this range, a small voltage variation allow precise control of the capacitance, making them ideal for fine tuning circuits. When we are talking about the RF and microwave applications, including voltage controlled oscillators and phase locked loop, normally PLL circuits, the voltage range is typically ranging from 5 volt to 20 volt. These higher voltages provide a broader capacitance tuning range, which is crucial for the frequency modulation and the signal processing. Actually, in high power and specialized application such as satellite communications and radar system, Varactor diodes may require even high voltages reaching 20 volt to 30 volts, or even sometimes it is more. So the exact voltage range varies based on the diode's material, structure, and the intended use. It is essential to operate within the manufacturer's specified voltage limits to ensure optimal performance and the longevity of the components. That's all.
Okay, so talking about doping concentration, how does doping concentration affect the performance of a Varactor diode?
So, based on variable doping, different kind of doping conditions, the capacitance, the factors that influence in this Varactor diode is one is the capacitance range, then the tuning sensitivity, and then the quality factor, that is what we call the Q factors. So, if we lightly doped the diode, lightly doped the diode like PN junction, so that it created, so there is a gradual depletion region changed, and that results in a wider capacitance and tuning range. So if you lightly dope it, its capacitance and tuning range is wider. If it is happily doped, then it's reversed. The depletion region become narrower, and the segment, and then this the overall capacitance variation and the capacitance what's the capacitance variation will be the lower. So it's just a reverse. Like if you lightly diode, lightly doped, then the capacitance and tuning range will be wider. If it is heavily diode, then it will be the lower. So it's just a reverse. You can say the reverse one.
Okay, so where are Varactor diodes commonly used in RF and microwave circuits?
Yeah, so like earlier, the Suresh sir have told is that these are generally being used at the tunable RF and microwave circuits to provide the voltage controlled capacitance tuning. Like if you want to, control the voltage, also the capacitance, tune out the capacitance, you can use it. Like voltage control oscillator VCOs, where earlier the Suresh have told that phase lock loops or frequency synthesis system, or commonly used in the RF transceiver, satellite communication, and radar systems. And then they can be used in the tunable bandpass filters, use adaptive RF front-end filtering, and then can be used in FM and frequency modulation and the phase modulation, and then can be used in automatic frequency control circuits like the radio receivers to stabilize the fine tuning of the frequency dynamically, because of it characteristic that the capacitance change with the voltage, and it act as a variable capacitor also the diode. So because of this characteristic, this amazing feature of this diode can be used in automatic frequency control, in radio receivers, and in antenna tuning units, all of their areas where we use this, and all these different circuits, all these circuit in those areas.
Okay, so how is the Varactor diode used in voltage control oscillators?
The a Varactor diode, also known as the Varicap or tuning diode, plays a crucial role in voltage controlled oscillators, normally known as VCOs, by providing the variable capacitance that enable frequency tuning. It is semiconductor diode, is specifically designed to operate in reverse bias, where its capacitance changes based on the applied voltage. This property makes it a essential component in RF circuits, communication systems, and the frequency modulation application. When we are talking about the working principle of the Varactor diode in VCO, so a VCO is an oscillator whose output frequency can be controlled by the external input voltage. The frequency of the oscillator is determined by the LC tank circuit, which consists of inductor L and the capacitor C, that is a LC. So it is known as LC tank circuit. The Varactor diode acts as a voltage dependent capacitor in this circuit. When the reverse bias voltage across the Varactor diode is increased, the depletion region widens, as explained by the Sinha, so leading to a decrease in the capacitance. Conversely, when the reverse bias voltage decreases, that depletion region narrows. So that is the very important phenomena. So it resulting in increase in capacitance. The change in the capacitance alters the resonant frequency of the LC circuit, thereby controlling the oscillator frequency of the VCO. When we are talking about the Varactor diode in a practical VCO circuits, actually in typical VCO design, the Varactor diode is placed in a parallel with the fixed capacitor and an inductor. A control voltage is applied to the Varactor diode through the biasing circuit, so which ensures proper operation without significantly affecting the oscillator's performance. As the control voltage varies, the capacitance of the Varactor diode changes, leading to a shift in the oscillator's output frequency. When we are talking about the application of the Varactor diode tuned VCOs, so RF and microwave communication, it is used in the frequency synthesizer, phase locked loop PLAs, and the tunable filters. When we are talking with the application in the FM and AM radio, it helps in automatic frequency tuning. And when we are talking about the telecommunication system, the essential is mobile network and satellite communication for the signal modulation. And in the radar or aeroplanes, it is used in the frequency agile system. That's all about this.
Okay, so what is the role of Varactor diode in frequency multipliers?
It is very important. And the role, when we are talking the role of the Varactor diode in frequency to multiplier, a Varactor diode, also known as the Varicap diode, is a semiconductor device that acts as a voltage control capacitor when reverse biased. In frequency multiplier, Varactor diodes are used to generate higher order harmonics of an input signal, enabling efficient frequency multiplication in RF and the microwave application. And now the question arises, how a Varactor diode works in a frequency multiplier? in frequency multiplier exploits to create a harmonics of an input signal. When an AC signal is applied to the varactor diode, its capacitance varies periodically due to the changes in the voltage. This non-linear behavior distorts the waveform and generates harmonic frequency such as 2F, 3F, 4F, and so on, where F is the fundamental frequency. So a frequency multiplier circuit is designed to extract a specific harmonic, for example, 2F, 2F for the frequency W, 3F for tripling, using the resonant circuit or the filter, while suppressing unwanted frequency. And what is the advantage of the varactor based frequency multiplier? So its advantage is it is high efficiency, low power loss compared to active transistor based multiplier, low noise, produces minimal phase noise, which is critical for the communication system, and the compact design enable minimization of the RF and the microwave circuits. When we are talking about the application of the varactor frequency multiplier, it is used in microwave communication, radar, satellite, and the RF transmitter. Frequency synthesis में essential in the PLL and the signal generator. And test and measurement equipments, it is used for precision RF frequency sources. These are the
Okay, so how does a varactor diode contribute to phase-locked loops?
Yeah, so Varactor diode plays a crucial role in voltage control oscillators (VCOs) within the phase control loop. Here is how it works. So, when the Varactor diode uh, used in the VCOs, it's a part of the resonant circuit, and its capacitance when it changes when the voltage is applied and with the change in the applied voltage. So at as the PLL adjusts the control voltage, it the modified the resonant frequency of the VCOs and allow PLL to loop lock into the maintained desired frequency. And in the frequency synthesis, if you want to if you want if you desire if you want to generate a desired precise frequency, so you can tune to that desired frequency by tuning the VCOs using the Varactor diode. uh, uh, yeah, and then in the frequency modulation and demodulation can be used in the similar way.
Okay. Why are varactor diodes preferred over mechanical tuning elements in filters and tuners?
Yeah, because of there is no moving parts. It's a totally circuit. So if you want to do the electrical tuning, like vector diode uh, helps you in tuning the elements and tuning out the whole circuit without even doing any kind of moving parts or potentiometer, but doing manually by the hand. You can do it. You can do it by controlling the voltage and do all those tuning using the circuits. And then miniaturization and integration, so you can miniaturize the whole circuit, like you can make the circuit compact, lightweight, and easy to integrate into the IC. So what we use in the modern RF and microwave circuits, you can easily tune it. You can make it a small, a smaller, compact, light size, because the same thing is working at the both thing, the variable capacitor, the capacitors, and the diode, and you can change those all those things and tune those frequencies and the very things by changing the voltage and all those. And the second is the higher reliability and durability. Since these vector diodes have no moving parts, there is no moving parts, there is no mechanical part presented there, so it's more reliable and have longer life than the the circuit with the moving parts or with some kind of mechanical parts out there. And better stability and accuracy, it gives you the smooth and precise tuning, while if you use the mechanical components, they suffer the hysteresis, backslash, and mechanical drift because of their mechanical arrangements. And as you know, these mechanical arrangements can be wear and tear with the time, but it's a total circuit. It's a total circuit. It's all the tuning circuits. Be using this, you can doing everything using the circuit. So it's there is no mechanical part. So it will live longer than the other one. And the suitable high frequency application like RF and microwave circuits, cellular networks, satellite communication, the radar, vector diode, Varactor diode offers low loss, high speed tuning, and improve stability. So these are the reasons because why we used and why we prefer these over the mechanical tuning system or mechanical tuning elements or filters.
Okay, so what parameters should be considered when selecting a Varactor diode for a circuit?
Actually, when we are selecting a Varactor diode for the circuit, several parameters must be carefully considered to ensure optimal performance. For example, we have to consider the capacitance range. The primary function of the Varactor diode is to provide the variable capacitance. The capacitance range should match the circuit's tuning requirement. It is usually specified at the different reverse bias voltages, typically from a few picofarad PF to several hundred PFs. Another parameter which we have to consider is the tuning ratio. This refers to the ratio of maximum to the minimum capacitance over a specified voltage range. A higher tuning ratio allows for a broader frequency adjustment range, which is the crucial in voltage controlled oscillators, VSOs, and the PLLs, phase lag loop. Another is the quality factor, normally known as Q factor. The Q factor determines the efficiency of the varactor. Higher Q values indicates lower losses, which is especially important in the area and the microwave applications to maintain the signal integrity. And the next is the uh, reverse breakdown voltage. It is a very important parameter in this. Actually, the diode must withstand the maximum applied reverse voltage without breaking down. Selecting a varactor with the sufficient breakdown voltage ensures reliability and the prevents premature failure. Next parameter which is important is the tuning voltage. The operating voltage range should design with the circuit's available control voltage. If the tuning voltage is too high, additional circuit may be needed to generate the required control voltage. Another parameter which we have to consider is the series resistance. Lower series resistance reduces power loss and improves circuit efficiency, making it a key parameter for the higher frequency application. Next parameter is the very important package type and the mounting. The physical package must be compatible with the circuit layout and the thermal dissipation requirements, especially in the compact or the high power applications.
Okay, so what parameters should be considered? Sorry, how does quality factor affect the performance of a Varactor diode in high frequency applications?
Yeah, the quality factor, normally known as Q factor, it is also a very important parameter in determining the performance of the Varactor diode, especially in high especially in high frequency applications such as voltage control oscillator COs, frequency multipliers, and the tunable filters. The Q factor represents the efficiency of the varactor diode by quantifying the ratio of the stored energy to energy dissipation per cycle. A higher Q factor means lower energy loss and better performance. So now we can say what impact on the high frequency applications. Oscillator is stability and the phase noise is very important. In VCOs, the Q factor of the vector directly affects phase noise. So a higher Q factor results in lower phase noise, improving signal purity and the frequency stability. Conversely, a low Q factor introduces more losses, leading to a degraded signal quality and they increase the phase noise. Next is the tuning effect and the linearity. What impact of this? At high quality character diode enable efficient tuning by minimizing resistive losses, ensuring a more linear and the predictable capacitance voltage relationship. This is essential for the application requiring precise frequency control such as RF communications and the radar system. Next parameter which impact is the insertion loss in the filters. In tunable filters, vector and the low Q values increases the insertion losses, reducing filter efficiency and the bandwidth. High Q vectors maintain better signal integrity, allowing for the sharper filter response and the improved selectivity. Next parameter is the power handling and heat dissipation. It is also very important, which impact this one. A high frequency parasitic resistance in a low Q vector leads to excessive power dissipation, generating heat that may impact the circuit performance and the reliability. So, a high Q vector minimize these losses, enhancing the efficiency.
Okay, so what are the challenges in designing circuit using varactor diode at high frequencies?
So there are few challenges that in designing the circuits using the Varactor diode. One is the non-linear capacitance variation. The capacitance and the voltage relation is non-linear, so they you can't make a precise tuning, and getting the precise tuning using this is a little bit challenges in comparison to others. And then the voltage control precision, as very small variation in the biased voltage can lead to the large frequency shift. So you have to maintain the reverse bias voltage, and do change in do variations in the reverse biased voltage very precisely and very accurately and more controlled way, so that your frequency shift didn't go to the very large extent. So that is one of the challenge, and apart from the previous one. And then the another challenge is the thermal effect. So like you already know that when you heat up the diode, the thermal conductivity changes in the diode. So even though it's the Varactor diode, so it's still the diode and the combination of capacitors acting as a circuit that has diode and capacitor both combined together. So even in this, the same problem that diode carries, it also inherits the same problem, the thermal effect. So if there is change in temperature, then the doping concentration and leading capacitance drift change, and because of the thermal effects, the change in temperature around itself. So these are the few challenges that you face. One is the non-linear, non-linear relation between the voltage and the bias voltage and the frequency shift, and then the thermal effect on the diode, and all these different kind of this small challenges that you face, and you have to uh, design your circuit according to that.
Okay. So, how does a Varactor diode compare with MEMS-based tunable capacitor?
Actually, the Varactor diode and MEMS based tunable capacitor serve similar functions in electronic circuit by providing a variable capacitance, but they differ significantly in the performance, design, and the application. First, consider the capacitance range and tuning ratio. Varactor diodes offer a capacitance range typically from few picofarad to several hundred picofarad with tuning ratio of around 3:1 to 10:1 ratio depending on the diode type. MEMS based tunable capacitors can provide a wider tuning range, often exceeding 10:1 with precise stepwise adjustment. Next parameter is the quality factor. MEMS capacitor generally have much higher Q factor than the Varactor diodes. Varactor suffers from the resistive losses due to their semiconductor nature, which results in lower Q factor, typically in the range of 50 to 200. MEMS capacitor being mechanical structure with minimal resistive losses can achieve Q factor above 1000, making them superior for the high frequency application requiring minimal design degradation. And the next parameter is the linearity and the signal distortion. Actually, Varactor diodes exhibits non-linear behavior due to their junction capacitance characteristics, leading to a signal distortion, particularly in RF application. MEMS capacitors, on the other hand, offer excellent linearity and the minimal distortion, making them the preferable for the high fidelity RF and the microwave circuits. Next parameter, which is important, is the power handling and the reliabilities. MEMS based capacitors can handle higher power levels with less thermal dissipation, whereas the Varactor diodes have the limited power handling due to junction heating and the breakdown voltage.
I think there is some internet issue with Suresh, sir. Ashwini ji, can you do you want to add anything to this question?
Yeah. I think I don't have much words to add. I think Suresh have already covered all those things what needed to be.
Okay, then moving on to the next question. Can a Schottky diode be, sorry, what are the advantages and disadvantages of using Varactor diode instead of a PIN diode in RF applications?
So, in case of the Varactor diode, you can get precise and continuous tuning and very smooth transitions and lower power consumptions. The as the Varactor diode worked in the reverse bias for the capacitance, it's take very low power consumptions in compared with to the pin diode, and then a smaller size and simplicity, easier to integrate into the RF designs and biasing networks, and better for high frequency and low loss application like low series resistance and high Q factor. These are the advantages of it, but if you go for the cons, the disadvantage of it, limited capacitance tuning. Varactors only provide variable capacitance wherever pin diode can act as a RF switches and variable alternators and phase shifter as well. A low power handling uh, capability. The Varactor diode are not designed for the high power application. At it also at so it is one of the its a disadvantage at that side, but on other side it can take you as advantage. It can work in very low power consumption. It consume very less amount of power. Yeah. So then is the non-linear capacitance behavior. So the relation between the voltage and the capacitance change is non-linear. I mean, you can't predict the capacitance with the variation of the voltage using the linear graph. So what we do, like if it change linearly, you can predict using the graph figure that at this voltage this is the amount of capacitor, at this voltage this is the amount of capacitor. The graph is linear in most of the case, but here it is not. The graph is not linear. It's the relation is not very linear. So you can't predict that at this voltage this is the exact capacitance. There might be the variation in that. So it's the relation is non-linear. Because of that, that is the challenges. And then I have already told you the one of the cons is the temperatures. Due to the temperature variations, they are very sensitive to those. So if the temperature changes around the diode, then it creates lots of variation and noise in the circuit.
Okay. So can a Schottky diode be used as a varactor, and why or why not?
Actually, no. As a static diode is generally not suitable for the use of as a Varactor diode. Due to its structural and the electrical characteristics. While both Scotty and the Varactor diodes are semiconductor devices, their primary functions and behavior differ significantly when considering about the junction capacitance behavior. In the Varactor diodes are specifically designed to exhibit a highly controllable capacitance that varies predictably with the reverse bias voltage. They have a well-defined depletion region aligned for a wide tuning range of the capacitance. Schottky diode, on the other hand, have a metal semiconductor junction rather than the PN junction. While they do exhibit some junction capacitance, it is typically small and not optimized for the tunability. And another difference is the tuning ratio and the linearity. Actually, the capacitance variation in the Schottky diodes is much less pronounced compared to the Varactor, leading to a poor tuning ratio. Varactor diodes are actually designed with a capacitance tuning ratio of around 3s to 1 to 10s to 1. Whereas the Schottky diodes have minimal capacitance variation, making them the ineffective for the precise tuning application. And the next is the high frequency performance. In Schottky diodes are widely used in high frequency applications due to their fast switching speed and the low forward voltage drop. However, their Q factors is not optimized for the low loss capacitance tuning, making them less efficient as the Varactor in RF application normally. And what another problem is the practical application. While Schottky diodes do exhibit some capacitance, they are primarily used for rectification, mixing and detection in the high speed circuits rather than for tuning purposes. So, Varactor diodes remain the preferred choice for the application, such as the voltage controlled oscillators, yani VCOs, frequency multiplexers, and the tuning filters. These are the factors by which we cannot replace the Schottky diodes in place of the Varactor diodes.
Okay, so now I'm done with all my questions. Anything else you people want to add to this topic? Any other information you want to share regarding this topic? Then please share. Otherwise, we can wind up.
You can wind up. I am.
Okay. Okay, so this brings us to the end of the session. I hope the discussion was very helpful to you all. If you have any question, you can post in the comment section. We'll get back to you in the next session. Thank you.